let's have a second practice about first order linear differential equations. So let's start by answering the first problem. So in the first problem, we have 2x times dy all over dx is equal to um, 3 minus y. Okay? So how would you find the general solution of a given first order linear differential equation? So first thing you need to do is to make it into a standard form first. How would you know if a first order linear differential equation is in standard form? So this is the format. dy all over dx plus p of x times y is equal to q of x. So this is the standard form of a first order linear differential equation. Okay, so first, what I'm going to do is I will transpose, I'll transpose y to the left side. Since a term that has a y variable should be together or should be grouped with dy all over dx. So we will put it here and we will have 2x dy all over dx plus y is equal to 3. Okay. And as you can see, the coefficient of your dy all over dx is 1. Or in other words, there shall be no coefficient for your dy all over dx except 1. Therefore, we will divide both sides by 2x. So as a result, we will have, why am I copying? So as a result, we will have dy all over dx plus 1 half of 2x, 1 all over 2x, times y is equal to 3 all over 2x. So this is already in standard form. Due to this, we can now figure out which one is your p of x and which one is your q of x. So your p of x is obviously partnered with your p of x. Thus, p of x is equal to 1 all over 2x. And for your q of x, should be on the right side of the equation. So your q of x is 3 all over 2x. That's it. Now, after that, what are we going to do? So since we have this one, let me erase this one. Okay. Since we already figured out which one is your p of x and q of x, now let's use this formula. Okay. First thing is you need to know its integrating factor. Okay. The integrating factor is u is equal to e raised to the integral of p of x. Wait, let me fix that. P of x dx. So, what is your p of x? Your p of x is 1 all over 2 of x, 1 all over 2x. Therefore, you will have u is equal to e raised to the integral of 1 all over 2x. Okay? So, I can bring out my 1 half outside of the integral. So, we will have 1 half times the integral of 1 all over x. So what would be the integral of 1 all over x? Your 1 all over x, then the integral of it, it's ln of x. So the integral of 1 all over x is ln of x. Okay. And we can still simplify this one. Okay. By the laws of logarithm, we can bring back 1 half to your x. So we will have u is equal to e raised to ln of x raised to 1 half. And remember, if we have e raised to ln of something, okay, for example, e raised to ln of a, what you're going to do is you're just gonna copy a. Because this is one of the laws of logarithms wherein if you have your e as your base and you have a ln function as your exponent, just copy the input. So e raised to ln of a is equal to a. So therefore, e raised to ln of x raised to 1 half is basically x raised to 1 half, or u is equal to the square root of your x. So that's it. Now, after that, you can now use this formula to find the general solution for your first order linear differential equation, which is u times y is equal to the integral of your u times q of x and yeah, dx. So let's copy your u. You will have square root of x times y is equal to the integral of square root of x. Then your q of x, you have uh, 3 all over 2 of uh, 3 all over 2x. Okay. So first, I can actually bring out the constant here because 3 all over 2 is a constant. So we will have the square root of x times y is equal to 3 all over 2 times the integral of square root of x times 1 all over x. Okay. Then, what can we do here is that we can simplify the, what's that? Square root of x and 1 all over x here. So recall, wait, let me copy this one. Okay. Recall that your square root of x is basically x raised to 1 half, and 1 all over x is x raised to negative 1. So if you're going to simplify this one, you will have, let me copy this again. Square root of x times y is equal to 3 halves times the integral of x raised to 1 half plus negative 1, or 1 half minus 1. So 1 half minus 1 is negative 1 half. So let's now integrate your x raised to negative 1 half. So the integral of x raised to, wait, sorry, the integral of x raised to negative 1 half. So we will have 3 half times 1 all over negative 1 half plus 1, wait, 1 all over negative 1 half plus 1 times x raised to negative 1 half plus 1. Okay, and don't forget your plus c. Okay, so here we will have, as a result of, so here we will have the result of 3 halves times 1 all over 1 half times x raised to 1 half plus c. So if you're going to simplify 1 all over 1 half, okay, this would be, what do you call this? This would be 3 halves times 2x raised to 1 half. Okay. So if you're asking me how did I get this one, I just simply reciprocate. So 1 all over 1 half, basically, in other words, is 1 times 2 all over 1. Okay? And since your 1 here is just a whole number, we can add 1 on your denominator. So 1 all over 1 times times 2 all over 1 will give you 2 as a result. So there you go. So that's it. So we can now have your x raised to 1 half into square root of x. Okay? We can rewrite x raised to 1 half to square root of x. And we can cancel out further. We will have square root of x times y is equal to 3 times square root of x plus c. So we can divide both sides by square root of x. We will have y is equal to 3 plus c all over square root of x. Okay? So this could be your final answer. Or you can have plus c times x raised to negative 1. Okay, so this is your final answer. Okay, or if you want, you can have this as your final answer as well. Okay, if you want, that's it. So either of the two, both of them are correct. Okay, now let's proceed to our second problem. So our second problem here is we have wait, let me write. There you go. Our second problem here is that we have 3x times 1 dt dy all over dx plus 3, okay, is equal to x squared minus y. Okay, so how are we going to make sure that this is in standard form of first order linear differential equation? Remember, once again, the standard form of your first order linear differential equation is dy all over dx plus p of x times y is equal to q of x. I remember this one. Okay, so first, what are we going to do? First things first is we will, what do you call this one? We will divide both sides by 3x. Okay, so we will have dy all over dx. Wait. Let me fix that. Dy all over dx, okay, plus 3 is equal to x squared all over 3x minus y all over 3x. Okay, so I can simplify this one. X squared all over 3x. X squared all over 3x, if you're going to simplify them, your x here will be cancelled and this one will be reduced to 1. Hence, we will have x all over, sorry, we will have x all over 3. Okay. Okay. So, what's next? Now, what are we, sorry, forgive me. Okay, I got choked for a second. Okay, forgive me. So what I'm going to do here now is, since we have a function of p of x and they're partnered with y, and you see this part, your term has your y here. Okay, so we can bring out negative, we can transpose negative y all over 3x to the left. Okay, so we will have dy all over dx plus y all over 3x plus 3 is equal to x all over 3. Okay. Now, in here, we have your 3 here. And as you can see, there is no constant here, right? So, why not let's join it to your key of x. It's okay. Okay? So if you're going to join 3 to your right side, we will have dy all over dx plus y all over 3x is equal to x all over 3 minus 3. Why did I bring up 3 to the right? Okay. First of all, it is a constant term. Okay. And as you can see, your p of x will only exist if it is partnered with y. So this one, okay, this is already your p of x times y. And you see, 3 is just a constant term. So what we can do is we can put it on the right side. So we have x all over 3 minus 3. And this one will be your q of x. So since this is already in standard form, okay, what we can do now is that we can label which one is your p of x and which one is your q of x. So your p of x, okay, will be 1 all over 3x. So how is that even possible? Because here, I can decompose them into this. From y all over 3 all over x into 1 all over 3x times y. And this is your p of x. So I'm going to label it here. Next is your q of x. Your q of x, on the other hand, would be basically on your right side. So we will have x all over 3 minus 3. Now, let's find your integrating factor. So your integrating factor here, let me erase this one. It is u is equal to, wait, u is equal to uh, e raised to the integral of, hold on, the integral of, what's this again? I forgot. Yeah, p of x times dx. Yeah. So remember that your p of x is 1/3, 1 all over 3x. So we will have u is equal to e raised to the integral of 1 all over 3x. So we can bring out the constant here. So we will have e raised to 1/3 times the integral of 1 all over x. So what is the integral of 1 all over x? This is e raised to 1/3 times ln of x. Okay? And we can simplify this one because remember, by the laws of logarithm, we can bring the exponent to your x. So we will have u is equal to e raised to ln of x raised to 1/3. And remember, again, e raised to ln of a is equal to a. If you have e as your base and you have an exponent of a ln, or basically a natural logarithmic function, just copy the input. So if we have e raised to ln of a, then your answer is a. So if we have e raised to ln of x raised to 1/3, we will have u is equal to x raised to 1/3. So after you get your integrating factor, now we will use this formula, which is u times y is equal to the integral of your u times q of x. So let's substitute. Your u is obviously x raised to 1/3 times y is equal to the integral of x raised to 1/3 times q of x. Your q of x is x all over 3 minus 3. So we can now simply distribute. So if I have x raised to 1/3 and then, wait, x raised to 1/3 y. So if I'm going to distribute this one on the first term, wait, let me check. Okay. So if I'm going to distribute x raised to 1/3 to x all over 3, I will have the integral of x raised to 4 all over 3 over 3 and minus 3x raised to 1/3. I simply distribute x to -3. Okay? So what are we going to do now is we will integrate. Okay? So by integrating, wait. So by integrating, we will have, for your first term, okay, we will have 1/3 times 1 all over 4 all over 3 plus 1 times x raised to 4 all over 3 plus 1 minus, let's integrate for this one, okay, this would be 3 times 1 all over 1/3 plus 1 times x raised to 1/3 plus 1. And don't forget your plus c. Okay. So yeah, I'm just gonna copy the I'm just gonna copy the left side. Yeah. So yeah, we will have 1/3 times 4/3 plus 1. We will have wait, let me calculate. 4/3 plus 1, 7 all over 3. Okay. Let me check if I'm correct. Wait, 4 all over 3 plus 1. Okay, I'm correct. Okay. Times x raised to 7 all over 3 minus 3 times 1 all over 4 thirds times x raised to 4 thirds. Okay? And plus. Now, let's simplify. Okay? If you're going to simplify 1 all over 7 over 3, you will have 1 third times 3 all over 7 times x raised to 7 all over 3. If you're going to simplify 1 all over 4 third, you will have 3 all over 4 times x raised to 4 thirds plus c. Okay? So, if you're asking me how I got from 1 all over 7 third to 3 all over 7, basically I reciprocate 1 all over 7 third. So reciprocate, we have 1 times 3 all over 7. And since your 1 here is just a whole number, we can have the denominator of 1. So 1 all over 1 times 3 all over 7, we will have 3 all over 7. Okay? So the same application as well on your fourth. So now let's, what do you call this one? Let's simplify because we have x raised to 1 third. So in here, we will cancel out your 1 here. So we will have 1 all over 7 times x raised to 7 all over 3. Okay? Because 3 on the denominator and on the numerator are the same, so they can be cancelled out. Minus, here 3 times 3, we will have 9 all over 4 times x raised to 4 thirds plus c. And we have x raised to 1 third times 1. Okay. So this could be now your final answer. Okay, this could be. Or if you want to simplify further, we can divide both sides by x raised to 1 third. We can do that. So if that's the case, okay, if we're going to simplify it, we will have y is equal to 1 all over 7 times x raised to, I think this is, for this one, from x raised to 7 all over 3, this would be squared. Okay, this would be squared. Okay, minus 9 all over 4 times x raised to 2 all over 3 plus c all over x raised to 1 third. Uh, x raised to 1 third. Or we can have c times x raised to negative 1 third. Okay, that is your final answer. So here's the thing. If you still don't get it, how come did I get x squared and x raised to 2 thirds? Okay, so let's do it slowly. Okay, so first, let me erase this one. Oh, no. Let me put it here. Okay, there we go. So this would be 3. Okay, so let's start first with this one. Okay, let's divide 1 all over 7 x raised to 7 third all over x raised to 1 third. Okay, so this would be 1 all over 7 x raised to 7 third all over x 1 third. So this one, we can rewrite this as x raised to 7 third all over 7 all over x raised to 1 third. Okay. Then, we will reciprocate. So this is x raised to 7 third all over 7 times this one will become 1 all over x raised to 1 third. Okay? Because this one, okay, this is, since this is a whole term on your denominator, so we will have x raised to 1 third all over 1. But since we have, what do you call this one? We have a, what do you call this one? Two fractions on the numerator and in your denominator. If you're going to reciprocate it, you're going to basically exchange the position of the x raised to 1/3 to your denominator and put 1 to your numerator. So you will have 1 all over x raised to 1/3. Basically, interchange the position. Okay? Why am I discussing this? Because this is actually basic. Anyways, so we will have um, we will have uh, x raised to 7/3 all over 7 times x raised to 1/3. That's it. However, we can actually simplify this one. Remember, if we have x raised to a all over x raised to b, despite the coefficients they have, yet they have the same variables, which is x, and they have their own exponent. So by the definition of laws of logarithm exponents, I mean, basically copy the base and subtract their exponent. So since they have the same base, we will have x raised to a minus b. So here we will have 1 all over 7 times x raised to 7 all over 3 minus 1 all over 3. So 7 all over 3 minus 1, minus 1 all over 3, you will have 6 all over 3. And we all know that 6 all over 3 is equal to 2. So we will have 1 all over 7 times x squared. That's how I got this one. Okay? And the way how I got the answer for your 1 all over 7 x squared is the same on how I got negative 9 all over 4 times x raised to 2 all over 3, or 2/3. Okay? So try to do it on your own, because what we're going to do is we're going to proceed to the next problem. Okay? So once again, this is your final answer. Okay? So now let's proceed to the third problem. So our third problem, it consists of trigonometric function. So for third problem, we have dy all over d theta, theta. So remember, your independent variable is theta. Okay, be very careful. So dy all over d theta is equal to secant theta plus y times tangent theta. Wait. No. I'm actually wrong. Is equal to cosecant theta plus y times cotangent theta. That's it. So as always, convert this one into the standard form. And what the standard form looks like: dy all over dx plus p of x times y is equal to q of x. And as you can see, remember, what are our dependent and independent variable? Our independent variable is your theta, and your y is your dependent variable. So therefore, what would be the format if your independent variable is theta? Therefore, you will have dy all over d theta plus p of theta times y is equal to q of theta. Okay? Remember, if your x is independent variable, so you will have p of x and q of x. But if your theta is your independent variable, which is like this one, therefore the input of your function p is theta. So p of theta, and we have q of theta. Okay? So be very careful. Now, yeah, where was I? Yeah, let's convert this one into standard form. Okay. So first and foremost, since this is actually simplified already, so I can easily determine which one is my P and which one is my Q. Remember that your P has a partner of Y. So which one of the trigonometric function has a partner of Y? It's this one, right? So that is your P. And we need to regroup this one to your dy all over d theta. So we will put it here. So we will have dy all over d theta minus y times cotangent of theta is equal to your cosecant of theta. Now, in here, we can now easily determine what is your p theta and your q of theta because this is already in standard form. Okay? It's already in standard form because we can now easily determine which is your p theta and your q of theta. So what is your p of theta? Your p of theta is your negative cotangent. We can separate this one by uh, decomposing it by negative cotangent times positive y. So here we will have negative cotangent of theta. Then your q of theta, that would be your cosecant theta. That's it. Okay. So now that we have already figured out which one is your p of theta and q of theta, we can now find your integrating factor. So remember that your integrating factor is u is equal to e raised to p of x and dx, right? Right? Do you remember that? Remember that your independent variable is theta. It's theta. Therefore, it is u is equal to e raised to p times raised to integral of p of theta times d of theta. Okay? Now let's substitute. Since your p theta is equal to negative cotangent of theta, so we will have u is equal to e raised to the integral of negative cotangent of theta. What is the integral of negative cotangent of theta? So the integral of negative cotangent of theta, this is e raised to, wait, raised to negative ln of sine theta. Okay? Because the integral of a cotangent theta is equal to ln of sine theta. Okay? So you can have e raised to, sorry. E raised to negative ln of sine theta. And remember that simplify by laws of logarithm, we have negative in here. So we're going to bring it to your sign. So you have u is equal to e raised to ln of, ln of sine theta raised to negative 1. Okay? So remember again, e raised to ln of a is equal to your a. So if you have a base of e, an exponent of ln, just copy the input. So since we have base of e and you have logarithmic function, to be specific, natural logarithmic function, so therefore you're going to copy the input. So hence you have u is equal to sine theta raised to negative 1. Or this is cosecant theta. Remember that sine theta raised to negative 1 is basically 1 all over sine theta. And remember that cosecant theta, cosecant theta is equal to 1 all over sine theta. So therefore, this is cosecant theta to simplify things. All right? Now, what we're going to do is we're going to use this formula. So you will have u times y is equal to the integral of your u times q of theta. Okay? Remember that the, what do you call this one? That the letters are changed. Since your independent variable is theta, therefore it should be in theta, not in x. Okay? Now we can substitute. So you have cosecant theta times y is equal to the integral of cosecant theta times cosecant theta. Okay? So here, if you're going to combine them together, we will have cosecant squared of theta. Okay, and we have y times cosecant of theta. So what is basically the integral of cosecant squared theta? The integral of cosecant squared theta, if you're going to recall, it is negative cotangent theta. Okay? If you don't understand what I mean, then I suggest you should review your calculus 2 or your integral calculus. Because the integral of cosecant squared theta is negative cotangent theta. So that's it. Okay? So this could be your final answer. Or you can simplify this one by dividing cosecant theta on both sides. So we will have y is equal to negative cotangent theta all over cosecant theta. Wait. All over cosecant theta plus c all over cosecant theta. So this could be also your final answer. Okay? It could be. Or you can still simplify it yet. Okay? You can still simplify. So what is the simplified form for this one? Remember that cotangent theta, wait, remember that cotangent theta is equal to cosine theta all over sine theta, if you're going to recall it. So this is y is equal to negative cosine theta all over sine theta. Okay, all over cosecant theta. Remember that cosecant theta is equal to 1 all over sine theta. So therefore, we will have 1 all over sine theta plus c all over 1 all over sine theta. So we can simplify. So for this case, for your first term, we will reciprocate. So we will have y is equal to negative cosine theta all over sine theta times sine theta all over 1 plus, for here, since we have c all over 1 all over sine theta, we will have c, okay, times sine theta all over 1. And since your c is just a whole term, we will have 1 as your denominator. So therefore, if you're going to simplify, y is equal to, this one will be cancelled out. So we will have negative cosine theta. And next here, we will have c times sine theta. So we will have c times sine theta. And that is your general solution. See? That's basically how you got the answer for this given problem. So let's have another problem. So our fourth problem will be x minus 5 times dy all over dx plus 4 times x minus 3 all over, all over x plus 3 times y is equal to 1. So this one is actually challenging. If you would observe it, this is actually challenging because first, we have a binomial, okay, binomial as a coefficient for dy all over dx. Then, we have a rational expression for your y, okay? So, it seems like this is challenging, but again, it's worth of a try, okay? So, first and foremost, make it into a standard form. So remember that the standard form is dy all over dx plus p of x times y is equal to q of x. Okay? So in here, so we're going to what? Basically divide both sides by x minus 5. Why? Because remember that in standard form, as you can see, there shall be no coefficient for your dy all over dx except 1. Okay, except 1. However, the coefficient for your dy all over dx is a binomial, which is x minus 5. Okay, so we need to divide both sides by x minus 5. So we will have dy all over dx plus 4 times quantity x minus 3 times all over x plus 3 all over x minus 5 times y is equal to 1 all over x minus 5. Okay? Now, as you can see, since in this term, we have, again, a complicated fraction. So we will simplify by reciprocating. So 4 times x minus 3 all over x plus 3. Okay? And since for this one, we have x minus 5, so we will have times 1 all over x minus 5. Okay? So how did I get that? So since your binomial x minus 5 has no fraction, just a whole polynomial function, we can have the denominator of 1. Okay? So therefore, if you're going to reciprocate, you will copy the numerator, which is this one, then times, change the position of the numerator and the denominator on your denominator part. So your x minus 5 will be here, and your 1 will be here. So we will have times 1 all over x minus 5. Basically, interchange the position. So now let's multiply. So we will have 4 times x minus 3 all over quantity x plus 3 times x minus 5. So that's it. Therefore, this would be the simplified form for um, your term on the second term, for your second term basically. So we will have this one. Okay, so that's it. There we go. Wait. Times y. Okay. Is this already in standard form? The answer is yes. It is already in standard form. Now, what we can do now is we will what? Label which one is p of x and q of x. So your p of x is basically this one. Okay? And your q of x is 1 all over 5, 1 all over x minus 5. So now that you have determined your p of x and q of x, we can now use your u to find your integrating factor. So the integrating factor here is u is equal to e raised to p of x. So remember, okay, since your p of x is this one, so we will have u is equal to e raised to this one, 4 times quantity x minus 3 all over x plus 3, quantity x plus 3 times quantity x minus 5. That's it. So, how can you integrate this one? So you can integrate this one by applying partial fractions. So let's focus on this part because this one is actually interesting. So let's get first the integral of this one. Okay. Now, um, since you have a constant of 4, we can bring out 4 outside. So I'll put 4 here. Okay. That's it. Okay. Now, if you're going to recall, when it comes to partial fractions, okay, if you have a factored form, which are this one, x plus 3 and x minus 5, then this would be, okay, 4 times the integral of a all over x plus 3 plus b times x minus 5 dx. Okay, so from this to this. But the question is, so we're going to take it slow. Okay, let's take it slow. Okay, so first let's focus on this one. Okay, let's focus on this one. Okay, so again, this one, x minus 3 all over quantity x plus 3 times quantity x minus 5. This is a all over x plus 3 plus b times x minus 5. So multiply the equation both sides by x plus 3 times x minus 5. We will have x minus 3 is equal to a times x minus 5 plus b times x plus 3. Okay, so that will be your working equation. Okay, so we have x minus 3. How did we get a times x minus 5? If you're going to multiply this this group of binomial to this one, what will happen is we will cancel out x plus 3. So we will have a times x minus 5. Then next, if we multiply this group of terms to b all over x minus 5, we will cancel out x minus 5 here, and we will have b times x plus 3. So this is our working equation. Now, since we have x plus 3 and x minus 5, so what if your x is equal to 5? So if your x is equal to 5, so we will have 5 minus 3 is equal to 5, sorry, a times 5 minus 5 plus b times 5 plus 3. So how did I get 5? How did I get 5? Right in your denominator or your factors, right, we have x plus 3 and x minus 5, right? So I want you to find the x for this one. Transpose 3 to the right, we will have negative 3. And transpose negative 5 to the right, we will have 5. So we will have 2 x's. So let's start first with your 5. Okay? So if your x is equal to 5, so 5 minus 3 is 2. So 8 times 0 plus 8 times b, because 5 plus 3 is 2. So we will have, so this one, 8 times 0 is 0. So we will have 0 plus 8b. So this is 2 is equal to 8b. And now let's find your b. So let's divide both sides by 8. We will have 1/4 is equal to your b. So that's it. That's for your b. Now, what if your x is equal to negative 3? Okay. What if your x is equal to negative 3? So we will have negative 3 minus 3 is equal to a times quantity negative 3 minus 5 plus b times negative 3 plus 3. So we will have negative 6 is equal to negative 3 minus 5, we will have negative 8. So negative 8 times a, we will have negative 8 times a. This one, we will have negative 3 plus 3, we will have 0. So b times 0. So this is negative 6 is equal to negative a plus 0. So we will have negative 6 is equal to negative 8, a. So by getting your a, we will divide both sides by negative 8. We will have positive 3/4. So since you have found your a and your b, therefore, the partial fraction, am I right? Yeah. Therefore, the, what do you call this one? The rational expression of this one will become like this, in which it will become, wait, I'm gonna erase this one, okay? Because I think I have no space. All right. Or you know what? Fine. I'm just gonna copy this one. Okay, wait. Let me just copy this. There you go. Copy. Then I will. Bring it here. That's it. There we go. So there we go. All right. So since we have A and your B, so we will have 3/4 all over x plus 3 plus your B 1/4 all over x minus 5. And if, once again, we have a fraction on the numerator, the same thing on the second term. What we're going to do is reciprocate. Okay, reciprocate. Just like what do you call this one? Just like what I did here on your y, we're going to reciprocate this one. So if you're going to reciprocate, so this would be 3 all over 4 times quantity x plus 3 minus 1 all over 4 times x minus 5. Okay? So therefore, you are going to use this one. Okay? You're going to use this one instead of this. Again, instead of using this one, you are going to use this expression. So therefore, we will have this one. Okay? So let me cut this one. All right. And after that, I'm going to erase this one because I'm going to save some spaces. All right. So that's it. So just basically go back, just uh, pass like 10 seconds. Okay. Or go back 10 seconds or 50 seconds and you will see it. Okay. So therefore, okay, you will have um, 4 times the integral of this one. Okay, you are going to use this one. Okay, so now let's find the integral for this. Okay, so first and foremost, I can factor out this expression by 1/4. So I will have 4 times 1/4 times the integral of 3 all over x plus 3 minus 1 all over x minus 5. Okay, so why did I do that? Because as you can see, on the first term and your second term, they have their greatest common factor. And their greatest common factor is 1/4. So I bring out 1/4 and we have this one. Okay. So how did I know if it's 1/4? I simply basically decompose this one. Okay. So basically, I will have uh, 4 times the integral of 1/4 times 3 all over x plus 3 minus 1/4 times 1 all over x minus 5. So factor it out. I will have 4 times 1/4 times the integral of 3 all over x plus 3 minus 1 all over x minus 5. Okay. So after that, 4 times 1/4 cancel out. We will have 1 or just simply as just invisible like that one. So we will have integral of 3 times 3 all over x plus 3 minus 1 all over x minus 5. That's it. Okay, so that's it. Now, what we're going to do is to integrate this one. So if you want to go to the point, the integral for this one is 3 times ln of x plus 3 minus ln of x minus 5. That's basically the integral for this one. So how did I get it? I used use substitution. Okay. So try to use substitution for this one. Okay. So let's do it slowly. So we have the integral of 3 all over x plus 3. Okay. So let u be x plus 3 and du be 1. Okay. 1 times dx or just dx. So we will have 3 all over u times du. So what is the integral of 1 all over u? This is ln of u. And remember that your u is x plus 3. So we will have 3 times ln of x plus 3. Okay? So that's how you get it. So the same thing here, okay? Try to do this one. Try to use u substitution for negative 1 all over x minus 5. Okay? Get the integral of. Okay? So either way, the answer, okay, for this one is basically, where was I? Yeah, this, yeah. The answer for this one is 3 times ln of x plus 3 minus ln of x minus 5. Okay, that's the integral for this one. Okay, since we already got the integral, we can now substitute it here. Okay, so we will have this. Okay, copy. Okay, and we will remove this one. So we will have um, u is equal to, wait. Oh, wait, Allah, it stopped working. Hold on for a second. Okay, I'm back. Sorry for the inconvenience. So let's go. All right, so where was I? Yeah, your final answer is u is equal to e raised to, never mind. This is 3 times ln of x plus 3 minus ln of x minus 5. Okay, and by the way, we can still simplify this one. Okay, we can still do that. All right, first and foremost, the exponent of 3. Okay, we can, no, wait. First and foremost, do not put the exponent first. I can separate this one. Remember that if you have e raised to a plus b, we can rewrite this as e raised to a times e raised to b. You know, we can separate this one. Okay, so if we have e raised to x minus y, we can rewrite this as e raised to x times e raised to negative y. Okay, so by doing so, we can have u is equal to e raised to 3 times ln of x plus 3 times e raised to negative ln of x minus 5. So what we can do now is we can now apply one of the laws of logarithm wherein the exponent you're going to put it here. The negative exponent you're going to put it here. So we will have u is equal to e raised to ln of x plus 3 raised to 3, and we have times e raised to ln of uh, x raised to 5, x minus 5 raised to negative 1. So remember again, e raised to ln of a is equal to a. So if you have a base of e and you have a function of ln of a, basically remove e and ln of a and just copy a. Okay? So therefore, we will have u is equal to x plus 3, x plus 3 raised to 3 times x minus 5 raised to negative 1, which is, if you're going to simplify it, this would be x plus 3 raised to 3 times 1 all over x minus 5. So we will have u is equal to x plus 3 raised to 3 all over x minus 5. That's it. That is your integrating factor. Now, since we have your integrating factor, what we can do now is we will find your general solution. So this would be u times y is equal to the integral of u times, q of x, q of x, then dx. So remember that your u is x plus 3 cube all over x minus 5 times y is equal to the same thing here as usual, x plus 3 cube all over x minus 5. okay, times your q of x, which is 1 all over x minus 5. Okay, so that is your q of x here. Okay, wait, am I right? Yeah, good, good. Okay, dx. So if you're going to, what do you call this one? If you're going to, wait. If you're going to combine them both, these two, you will have the integral of x3 raised to 3 all over the square of x minus 5. And as you can see, this is actually longer than I was expecting it to be. Okay, so what are we going to do here? Obviously, we're going to get the integral for this one. Okay, so how can we get the integral for this one? So first, you need to simplify it. Then after you simplify it, we're going to apply partial fraction. So let's try to do it with long division. Okay, because this one, as you can see, if there is a highest degree here, okay, of the numerator, which is again higher than the degree in your denominator, you need to simplify this one. Then after you simplify this one, you can apply partial fractions. So now let's what do you call this one? Now let's uh, get the integral for this one. Okay, so that we will not having a hard time, and we can just simply substitute. Okay, so where should I put? Let's just start here. Okay, so that we can have occupation of more spaces. Okay, so let me draw a border. So the border here, border there. We will start right there. Okay, so yeah, there we go. Okay. First and foremost, we need to expand this what do you call this one? Expand this binomial. This one is cube of binomial. We need to expand that one. And we need to expand this one. How do you expand a cube of binomial? Okay, there are like 4 steps. Okay. The first step is you need to cube the first term. Okay. Then the second step is you're going to have 3 times the square of your first term times the second term. Then your third step is 3 times your first term times the square of your second term. And lastly, your last step is you're going to cube the last term. Okay, let's do it slowly. Okay, let's do it slowly. Cube the first term. So what's your first term? Your x cube. Sorry, your x. So what's the cube of your x? It's your x cube, right? Next, your second step, 3 times the square of your first term times the second term. So we will have plus 3 times the square of your first term. It is x. Okay? You're going to square your first term, x, which is x squared. Okay? Times your second term is 3. So times 3. So 3 times x squared times 3, we will have 9x squared. Okay? Third step, 3 times the first term. So 3 times your first term is your x times the square of your second term, which is 9. So 3 times x times 9. So 3 times x times 9, this is 27x. Am I right? Yeah, 27x because 3 times 9. Yeah, okay. Then last is you're going to cube the second term. So this is your second term. The cube of second term is 27. So that's it. Okay, that's how you do it. Okay, if you're going to cube if you're going to expand a cube of binomial. Now, how about for your what do you call this one? How about for your the square of binomial, which is this one, because this one is in the exponent of 2. So there are only 3 steps. First step is square the first term. The second step is 2 times the first term times the second term. And the third step is square your second term. Okay? Square your second term. Now let's do that. Okay? So first, square the first term. So this is your first term. So this is x squared. Next, 2 times the first term times the second term, negative 5. So 2 times x, 2x, times negative 5, negative 10x. So you'll have negative 10x. And lastly, square the second term. So the square of negative 5 is 25. Okay, so that's it. All right. Now, we can now apply long division. Okay, let's now apply long division. Okay. Oh, sorry. So we're going to copy. Okay, okay. So we're going to copy this one. Okay. So why do we need to do long division again? Because we need to simplify your what? Your rational expression. Okay, because if there's a highest degree on your numerator compared to your denominator, you need to simplify it. Okay, so let's proceed. Okay, this is gonna be long, guys. So I hope you will learn something from this one. That's why I'm actually quick in explaining. In explanation. So we have x cubed plus 9x squared plus 27x plus 27. Okay, divided by x squared minus 10x plus 25. Okay, so first things first, get the first term and divide it by this one. So x cubed divided by x squared. So if you're going to divide x cubed by x squared, this would be x raised to 3 minus 2, which would be x raised to 1 or x. So you're going to put it here. So this would be x. So x times x cubed, x squared. So you will have x cubed minus x times 10x, you will have 10x squared plus 25x. So plus 25, so you will have 25x. And you're going to subtract them both. So if there is a subtract sign to your next polynomial, you're going to distribute it here. Okay, distribute the negative sign to each of the terms in this polynomial. So hence, you will have negative x cubed plus 10x squared minus 25x. So now let's combine x cubed minus x cubed, cancel out. 9x squared plus 10x squared, we have 19x squared. 27x minus 25x, we will have plus 2x. Okay, 75. Okay, good. Okay, then bring down 27. Okay, and as always, get this one, 19x squared, divided by your x squared. So we will have 9x squared. We will have 19x squared divided by x squared. So since we have x squared on the top and on the denominator, we can cancel them out, which we will have 19 as a result, or positive 19. So therefore, we will put it here. Okay, so we will have plus 19. So 19 times x squared, so we will have 19x squared. Next, 19 times negative 10x, so we will have negative 190x. By the way, this is 19. Wait, let me fix this one. So this is 19. Okay. Then next, 19 times 25. If I'm correct, this is supposed to be 475. Yeah, I'm correct. It's 475. So 19 times 25 is 475. So you're going to subtract them both. And since the minus sign, it is in this polynomial, so you're going to distribute the negative sign to these terms. So what we will have here is we will have negative 19x squared plus 190x minus 475. So let's subtract 19x squared minus 19x squared. This would be cancelled. Next, 2x plus 190. So we will have 192x. And lastly, 27 minus 475, we will have negative 448. And as you can see, we will stop right here because this one is no longer um what do you call this one? This is no longer factorable by x squared. Okay? Again, we will stop right here because this is no longer factorable by x squared. Okay? How will you know if it's not factorable? Divide 192x, 192x by x squared. So since we have x and x squared below, so we will be canceling x on the top, and this one will be reduced by 1. So we will have 192 all over x. So this is not obviously factorable. So we're going to stop right here. Okay, we will stop right here. Okay, so therefore, what would be the simplified form? The simplified form is x plus 19 plus 192x minus 448 all over x squared minus 10x plus 25. That is the simplified version for this one. Okay, so wait, let me check if I could simplify 192 and 448. Okay, so wait a minute. Okay, so this one, we can actually simplify 192x and negative 448. So we will have x plus 19 plus, okay, for 192, wait. What is this divisible by 192 and negative 48? Okay, 3. 192 divided by 64, 48 divided by 64. Okay. So this binomial are divisible by 64. So we will have 64 times 3x minus 7. Okay? All over x squared minus 10x plus 25. So this would be now your simplified version. Okay? This would be now your simplified version for this one. So we will have is equal to the integral of this one. Okay? So wait. This is the result. Okay? Let me erase this one because this is irritating. Okay, where was I? Yeah, we're going to put it. Okay. So, yeah, are we done though? Nope, we're not done yet. Yet, I'm not kidding, we're not done. Let me erase this one. No. There you go, and there we go. Okay. So in here, we can easily integrate x and 19. However, we cannot simply integrate this one. Therefore, you're going to apply partial fractions. So we're going to we're going to, wait. We're going to simplify this one into a decomposed fraction form. So remember that we have 64 times 3x minus 7, right? Is equal to the square of x minus 5. Remember that this one is equal to the square of x minus 5. Okay? We already got that from here, right? So when we square x minus 5, right, we have x squared minus 10x plus 25. So let's bring it back. So we have the square of x minus 5. Now, let's do partial fraction. So for this case, okay, this one, this is the same as what? A all over, um, sorry, A all over x minus 5 plus b all over the square of x minus 5. Okay, so we're going to use partial fraction second case, which is repeating factor. Okay, because if we have this one, then you're going to do like this: x minus 5, then x minus 5 squared. So yeah, let's proceed. Okay, let's multiply both sides by x minus 5 squared. Okay, so to do this one, okay, so we will have 4 times 3x minus 7 is equal to a times, if you're going to multiply the square of x minus 5 to your a, we will have a times x minus 5. B all over x minus 5 squared times uh, the square of x minus 5, we will have b. Because if you're going to multiply this one, the square of x minus 5 to b all over x minus 5, 5 squared, this will be cancelled out. So we will have b as your final answer. Okay? So again, if you're going to multiply the square of x minus 5 to your b, this will be cancelled out. So we will have b as your final answer. So now, what we're going to do is to substitute first. Since we have x minus 5, right? Okay, it is actually in square. Okay, now let's get your value of x here. So square root of both sides, we will have x minus 5 is equal to 0. And transpose negative 5 to the right, we will have x is equal to 5. So if we have x is equal to 5, then we will have 64. Then quantity 3 times 5 minus 7 is equal to a times quantity 5 minus 5 plus b. So 64 times 3 times 5 is 15 minus 7 is equal to a times 0 plus b. So 0 times a is will be 0 plus b. And this one, 15 minus 7, I think that's 6. Sorry, it's 8. So 15 minus 7 is 8. All right. So yeah, 15 minus 7 is 8. So 8 times 64, we will have 512. Am I right? 64 times 8. Wait, 64 times 8. I am correct. Then 0 plus b is b. So your b is equal to 512. Now, how will you find your a? So recall, if you have learned this in your discussion about partial fraction, what we're going to do is we're going to, what do you call this one? We're going to relate similar terms on both sides. So first, let's distribute. 64 times 3, we will have 192x. And next, 64 times 7, we will have 448. Okay. Then here we have ax minus 5a plus b. Okay. Now let's relate. Okay. So remember, when I say relate, basically, what will be your similar terms on the left? You're going to equate it as well to your right side. For example, here, on your left side, we have 192x, right? So if we have 192x, and this is the only term that has x, do you think on the right side, there's also a term that has x? The answer is yes. And what would that be? Your ax. So since both of them are similar terms because both of them are x, so we will have 192x is equal to ax. Okay? And since we have x on both sides, we will cancel out. So we will have 192 is equal to your a. And this is your a already. Finish. Yeah, I'm not kidding. It's finished. That is your A. But if you want me to prove it to you, if your a is equal to 192, then it's okay. All right. So next, how about this one? We have a constant term on the left. Your constant term is negative 448. Do you think on the right side, there's also a constant term? The answer is yes. There is also a constant term. And what are those? Negative 5a and your b. Remember your a and your b, these are just letters, but they are also constant terms. So negative 5 times a is the same as constant times constant. So constant times constant is still a constant. Okay? So therefore, we will have negative 488 is equal to negative 5a plus b. Now, let's prove if your A here is equal to 192. Let's prove it, okay? Before we proceed on integrating. So, remember that your B is equal to 512, right? So, we will have negative 488 is equal to negative 5 times A plus 512. Transpose this on the left side, we will have negative 512 minus 448 is equal to negative 5a. So, negative 448 minus 512, we will have negative 960 is equal to negative 5. And to get your a, we will divide both sides by negative 5. We will have positive 192 is equal to your a. So you see, it is proven that your a is equal to 192. So since we know now our a and your b, we can now substitute it to your what? Partial fractions. Okay, so let me copy it right here. Okay, let me put it here. Okay, and I'm going to erase this one. Okay, you can just skip like 5 seconds or 15 seconds at least so that you can go back what I did. So since that you have your A as your 192 and you have 512 as your B, therefore you will have 192 all over x minus 5 plus 512 all over the square of x minus 5. So that will be your shortcut or your partial fraction for this one. Okay, so we will have, let me copy this one. Wait, let me copy this. Okay, okay, let me copy that one. So we will have, okay, is equal to the integral of x plus 19 plus this one. There you go. Okay, and that's it. So now we can now simply integrate. So let me now remove this one. Let me now remove this. Okay. So what is now the integral for this expression? So the integral of x is 1/2 x squared plus the integral of 19, since it is a constant, so you will have 19x. How about this one? How will you get the integral for this? The integral for this one, okay, you will use substitution. Remember what I did here? Remember how I got the integral for this one? Okay, especially this, the u substitution thing, you remember that? You're going to do it here. Okay, you're going to do it here. Okay, try it by yourself. Okay, because I think I have no more time left. Forgive me. So the integral for 192 all over x minus 5 is 192 times ln of x minus 5. Okay. Now let's get the integral for this one. So for this one, the integral of 512 all over the square of x minus 5. Let me be sure, maybe I might be wrong. So the integral of 512 all over x minus 5 raised to 2. So we're going to apply u substitution. Your u is equal to x minus 5. So du, so you're going to have 1 times dx or dx only. So we will have 512 all over u squared times du. So bring out 512 because that's your constant times the integral of 1 all over u squared, which is the same as the integral of u raised to negative 2. Okay? 1 all over u squared is the same as u raised to negative 2. And remember, u raised to negative 2 happens if there is a base and there's an exponent on the denominator. Okay? So I hope you understand what I mean here because this one, like what I did here, from this to this one is basically an application of laws of exponents. Okay. Now let's get the integral for this one. So this would be 512 times u raised to, wait, 1 all over negative 2 plus 1 times u raised to negative 2 plus 1 plus c. So you will have 512 times what equals 1 times u raised to negative 1 all over negative 1. So you will have what equals 1? You will have 500 and wait, sorry. You will have negative 512 raised to negative 1 plus c or negative 512 all over u plus c. Okay? Because if you have a negative exponent, you can make it into a denominator. U raised to negative x is equal to 1 all over u raised to x. So if you have negative exponents, you can bring it down to your denominator. Okay? So after that, we can now substitute back. Since your u is equal to x minus 5, we will have negative 512 all over x minus 5 plus c. Okay? So therefore, the integral of 512 all over the square of x minus 5 is negative 512 all over x minus 5 plus c. And that is basically the whole integral for this one. Okay? So we will remove this with as usual. Okay? So now, let's go back. Where was I? Yeah, put a red color. So let's go back here. Okay. So on this case, okay, you will have x plus 3 squared all over x minus 5 times y is equal to the integral of this one, which is this. Okay, which is this one. That's it. Okay. Now, this could be your final answer. Okay, this could be your final answer. Again, it could be. Okay, it could be because we can still simplify this one. So let's try to multiply. So let's try to simplify this one. We can cross multiply because we have a denominator of x minus 5. So x minus 5 times that expression. So we will have x plus 3 squared, x plus 3 square of y is equal to 1 half x squared times x minus 5 plus 19x times quantity x minus 5 plus 192, wait, 192 times x minus 5 times ln of x minus 5. Okay, there we go. And then, what do you call this one? And then, here, this would be minus 512. Because if you're going to multiply x minus 5 to negative 512 all over x minus 5, the x minus 5 on the denominator will be cancelled. Okay? Negative 512 all over x minus 5 times x minus 5. So cancel out, you will have negative 512. Okay? So that's how you got it. Okay? plus, yeah, plus C times quantity x minus 5. Okay, so that's it. All right. Also, we can, uh, what do you call this one? We can leave this as your final answer. Again, we can only leave this as your final answer if you want to stop. But if you want me to simplify further, then there is no problem to me at all. So since we have x squared, the square of x plus 3, right? So we can divide both sides by the square of x plus 3. Okay? So we will have y is equal to 1 half x squared times uh, x minus 5. Wait. We will have x squared times x minus 5 all over 2 times the square of x plus 3 plus 19x times quantity x minus 5 all over the square of x plus 3. Wait, finally. There you go. Plus 192 times x minus 5 all over the square of x plus 3 plus ln of x minus 5, okay, minus 512 all over the square of x plus 3 plus c times quantity x minus 5 all over the square of x plus 3. Okay, so it is long. So you can stop right now if you like to. Okay, if you like to, you can stop right now. Okay, but for me, I'm not done yet. You can simplify this one. Okay, thoroughly. It's up to you. For me, I'm going to do, I think, uh, yeah, I'm going to simplify this term only. Okay. Remember the laws of logarithm. You can make this one as a exponent for your x minus 5. We can do that. So let me just copy this one. Your y is equal to, let me copy this one. Okay. So we will have this. Okay. Then for this one, by applying the laws of logarithm, we can put this thing, your coefficient of ln of x minus 5 as an exponent of your x minus 5. So we will have ln of uh, x minus 5 raised to 192 times x minus 5 all over x plus 3 raised to 2. Okay. Then you're going to copy the other terms here. So yeah, that is your final answer. So yeah, that's it, guys. That's how you get your final answer here. Okay, so that's it. And I think I'm gonna stop right now. I would love to continue more, but for the sake of my time, I'm going to stop right now. So thank you once again, and I hope you have learned something. And forgive me for being too fast because I am actually following a time limit here. So anyways, that is all, and thank you.